Okay, today we have a session for participants of ZKP use cases contest for presenting their submission. So I think everybody's here. So I can see Thomas, Fabrice, Noam, who's Idealatum? Is he here? Alexander, are you here?
I think the only Alexander here right now is you.
Okay, it looks like Alexander is absent, but
Have you tried pinging him on PM or something? Well, the contest requirements were at time convenient, so maybe we would have, if you won't show up, we would have to schedule a separate test for him, I guess.
he answered. Okay, so I think we could. I will send him a link. One moment. He told me he is coming now. Okay, so
hello. Oh, okay. Can you hear me?
Yes, I can hear you, Noam. I can hear Piotr.
Yes, Piotr. Everyone.
Yeah, and I think Alexander is came here. Alexander, hello. Okay, so everybody is here. So let's start then. So first submission is Fabian and Thomas. Who will?
It's Fabrice.
Fabrice and Thomas.
And Thomas, myself, yes. I think screen sharing is deactivated, which makes my task a bit harder.
You could
but
share
in the meantime, we're very happy to present our submission today. Hello, everyone.
Yeah, you could.
Yes, you can share it now.
There you go. Okay. So here. So I'm going to present. So Fabrice and I presented 3 use cases in our submission. So I'm going to be presenting the Sudoku instance, and then Fabrice will present the project Euler and the passcode instances, so-called. And so, well, without further ado, so what the Sudoku instance does is that you have a smart contract which has been given an instance of a Sudoku game. And what the user does is that they submit a zero-knowledge proof that they have one solution to this Sudoku. And so we limited ourselves to 4x4 Sudokus, as you'll see, because we had a compilation problem with 9x9, and we weren't able to resolve this in time. But in principle, we have all the code needed for that. So the first step is, so we use our own in-house tool called FT. And so I have this script which initiates a sandbox. So in this case called sandbox1. Here it starts. So I create a sandbox using the nil local node. And then I start the node. And then I give some money to some users in order to be able to do some tests. And as you see, the sandbox is initiated. So the first thing I will do is generate the keys. So as always with zkSNARKs, we need to generate a verification key and a proving key. So I called my C++ file to generate keys. So here they are. So we can see we have proof key.bin and verif key.bin have been created. So I actually zip my proving key. This is because we decided to put the proving key on the contract to help anyone who wants to submit a solution to have the updated proving key. And so here I have this little script that converts an instance. So this is an instance. So it's a very unconstrained instance. So it only forces the last square to be 1, and all the other ones are undetermined. And so I deploy my contract. So here's the command. So ft contract deploy Sudoku. So this is the ft syntax. You're giving it a large amount of tons, so 10 tons, just for in order not to have to think about it. Deployed by user 0, which is a default user. I give the verification key using this syntax. So it goes to fetch the file and then convert it to hexadecimal. And then the instance, which I generated in the right format using a small bash script. So if you have any questions, I can explain it. It's really not important. So the contract is deployed, it receives its 10 tons, and then we get a success. We can actually look at the Sudoku account. We see that it has a little bit less than 10 tons because some of the money was used, of course, for the deployments. So we're now trying to create a proof for the solution, which you can see at the bottom left of the screen, which, as you can see, is a valid solution to the instance here. So for this, I call my client with the generate proof subcommand. So here, ft-exec is just a way to say, okay, execute this binary. And so the actual binary is here, Sudoku client with the option Sudoku generate proof, and with the initial instance and the initial solution. Note that the initial instance is the primary input in the parlance of zkSNARKs, and initial solution is the secret input, the auxiliary input, if I'm correct. And then you see that the proof has been generated. So let's just keep this proof on the side because I'll use it later for something else. And then let's submit the proof. So I call Sudoku the method submit with the proof. And I tell ft to wait for the answer, and immediately I get, so actually quite a large answer. It's because I decided to have the contract spit out as well the proof, the complete proof. So the verification key, the primary inputs, and the actual proof. And here you can see that the result is true. So this means that the proof was accepted. Now we're going to look at a new instance. So this instance is a bit more constrained. And I'm going to submit this instance to the contract. So successfully. I can, using a get function, I can actually fetch. Oh, sorry, I copied the wrong command. So if I call ft call Sudoku, the function get is a getter that I wrote in Solidity. You can see the -- local here, which means that the command is executed only locally on my computer, so it doesn't cost any gas. And it's a function that gives me some of the parameters of the contract, so that there are 16 squares. So this means it's a 4x4 Sudoku, not 9x9. It gives you the current instance. So these are, for example, the square 0, 0 has value 1, square 0, 1 has value 2, etc. So it's the instance I showed you earlier. And then the verification key as well is in the states. Okay, and now what we're going to do is check that we can't do just anything. So I'm going to try to generate a proof for this false solution here. So which is obviously false because it doesn't have 1, 2, 3, and 4 on every line, column, and box. It doesn't have a single 4. So we expect when we run the generate proof to get a failure, and we do get an assertion constraint system is satisfied failed. So it's about as clear an error as we could get. But what if now we try to submit the initial successful proof? So this is why I kept the value here. So sorry. Here, I submit the initial proof to this new instance. So this is a proof that was accepted for the previous instance, but now we can see that it's not accepted because the instance has changed and the solution that we had for the first instance is no longer valid. So that's it for my part. As you can see, this is really a very toy use case, but it was a quite interesting way to get into the amazing library from Nil Foundation and to think a bit about how to encode mathematically the Sudoku. So I can answer some questions about this if there are any, but in the meantime, I'm going to give the mic to Fabrice, unless there are some questions.
Yeah, I have a questions. You are using your wallet, your own wallet. Is it possible to do the same using Tonos CLI utility?
It is. I mean, I wouldn't be able to do it off the top of my head right now, but of course, it's we're not doing anything that can't be done with TonOS SE. Is that, were you asking me to do it right now, or did you ask, is it in principle possible?
No, I want to ask, do you have something particular, some features in your wallet FC, which we do not have in Tonos CLI utility?
I think maybe Fabrice can answer this better than I can.
Yes. Do you hear me? So yes, FT has some features that are not in TonOS CLI, but mainly it's about the fact that it can handle several accounts. So you see there was user 0, but you can have you can associate different users to different addresses and so on. So it's quite easy to manipulate many accounts. But otherwise, everything it does, it uses the same SDK as the standard TonOS CLI, and so there is nothing it can do that cannot be done by TonOS CLI. Actually, there is even an option to use TonOS CLI from FT. If you want to, if you don't trust, for example, what FT is doing, then you can ask it to use the TonOS CLI in the background to be sure.
Okay, thank you. So I will try to repeat all the steps using Tonos CLI. Okay.
Okay, but so actually there is a Docker version of FT. Anyway, the source code of FT is available. So if you want to use it, it's quite easy, especially using the Docker version. And from the Docker version, using this particular option, you can use it. I mean, you can type the command of FT, and then it will output you the TonOS CLI version of the command. So you can, that way, you can translate from one to the other.
Great, great. Okay, so does anybody have has any other questions for Thomas?
Yes. Can I ask a question about your implementation of brute force? So as you point out in submission, that you implement brute force protection for 20 seconds based on SH8256 calculation. Can you show example how you do this?
So I think this is what Fabrice is going to show right now.
Is my screen shared? Yes. So yes, there are two other use cases in our submission. One is about Euler problems, and the other one is about changing the pub key of a user when he has lost his secret key. So the first one, I think it's the one that you are referring to. So the idea is that we want to create an infrastructure to publish Euler problems. So Euler problems are well, famous problems that sort of kind of contest where people try to solve mathematical problems, and they have usually an integer solution to provide to show that they have solved the problem. And the idea is that you want to do it online so that people can have a proof that they have solved a particular problem. So the idea will be that the publisher of the problem is going to create a circuit with the solution of the problem. So the solution is not public, but users can submit their proofs that they have the solution, and and then the contract is going to prove that indeed to check if the proof is correct, and if it is correct, then they will be registered as having solved the problem. So if I start, well, I should have done that before, but I'm going to, so I create a sandbox exactly the same way as Thomas did. Well, it's a bit slow. Okay. So I am going to give some so it's exactly the same script. So I create a sandbox with a nil image, and then I create a few users with some tokens. Here I'm going to define a few variables. So I will work with a problem that has the number 101, and the creator of the problem is going to add a nonce, a random number to that problem, so that somebody cannot try to prepare to brute force the solution before the problem is published. So because it doesn't know the nonce, even if it tries to create reverse images of hashes, they won't be useful since it doesn't know the nonce. And for that problem, I suppose that the solution is 777. So in the next steps. So the first thing I'm going to do is create the circuit for that problem. So I call the Euler client, our C++ client, with the prepare subcommand. I give it the problem number, the nonce number, and the solution. And so he is going to compute 1 million recursion of SHA-256, and that lasts around 20 seconds, at least on my computer. So maybe it's faster on other computers. But anyway, as soon as it takes a few seconds, then it means that if you want to explore all the possible values, then it will take a few days, and then successful candidates will anyway have solved the problem by that time. So you will not be the winner anyway. So now, using the prepare subcommand, I have a proof key bin file and a verif key bin file. As Thomas did, I will compress the solution so that it can be published online, because people will want to verify, to check to generate proofs on their computers, so they need to be able to download those proofs. And then I will first deploy the first part of the infrastructure of the the first part of the infrastructure, which is the root of the infrastructure. So it's a contract where all the problems and all the users will register. So I deploy the contract is called Euler. So it's Euler.sol. I give it some tokens, and I give it also the code of the two contracts is going to deploy. So there is a Euler problem contract and Euler user contract. So this is deployed. You can see that the contract here has been deployed to this address, and it's named Euler root. Now, what I can do is I can create a problem. So maybe I will show you the command before calling it. So it's here. So I call this root contract with the new problem method, and I will give it the number of the problem, the verification key of the problem, the proving key zipped of the problem. I give it the nonce, so it's taking it in the environment variable. I give it a title to a description. So here the title and the description are quite simple, but of course it could be much longer. And I give it an URL that should be on the Euler.org infrastructure normally. So I can call this, and then the contract is deployed. The problem contract is deployed. I will try to register this address in my in FT. So here, what I have done is that I have taken the address of the problem and I have named it Euler problem. So it's the name of the address in my client. So now I am a user, so I will create a user contract for me in the infrastructure. So I am going to call the new user method of Euler root with my pub key. So you see a pub key, and I am taking the pub key of the account user1. So this is sent to the contract. Now I am going to recover. So I'm going to create a local user, a local account on my computer with that address, the address that was created for this contract. And now, for example, what I can do is I can associate a name. So I am going to associate the name John Doe to this Euler user, so that people that are going to check who is this user are going to be able to identify him. So I can check, that I can call the get method of Euler user to see that for now, this user, that is John Doe, has solved no problem. Now, I am going to, as a user, I am going to create a proof that I have a solution. So of course, I have a solution on my computer since I am the one who created it. So I will call the proof subcommand of Euler client, giving it the problem, the nonce, the solution, and of course, I will give it also my pub key so that the proof is associated to my pub key. The reason for that is that we don't want other users to be able to use my proof for their own pub keys. So again, I have to wait for 20 seconds on average to generate the solution, the proof. And then once it's done, I am going to submit it on the infrastructure. So, okay. It's a bit slow. I don't know why. So, okay. So it has generated the proof.bin file, that is the one containing my proof. So I am going to submit it online. So I am going to call my user contract with the submit method. I will tell him that I want to solve the problem 101, and I will give it the proof from the file that has just been generated. and I'm going to sign with as a user one, of course, because the proof is associated with user one. So of course, since we are on a sandbox on a Tono SSE, everything is happening very fast. But on the remote network, it would last much longer. But here you can see that my request has been sent with these parameters. So it's here, and first. Sorry, I am lost in the. Well, okay. I think there were two. So there is at least one event that is generated here that says that the problem 101 has been solved by this pub key, so it's mine. And I think there was another one, so maybe it's above. So anyway, I don't see it. Called as solved. Okay, so it's weird, but anyway, okay. So it has been submitted. Now I can check if my user has registered the fact that I have solved the problem. Yes. So you can see that among the list of solved problems, there is this problem with the time when it was solved. And if I called the problem contract itself, so Euler problem is the problem contract, sorry, does not exist. So I've done a mistake somewhere. I think I didn't correctly register. Is it this one? No, but it's okay. So maybe it's this thing, but so there is a problem. But anyway, visibly I cannot call. So I think I did something wrong in my scripts. But anyway, if you list the Euler problem, if you take the Euler problem corresponding to this one, you would find that in the top 10 of users that solve this problem, I would appear with the correct solution. So I won't be able to, I plan to do a replay attack, but I cannot do it because, well, I could do it. For example, I could submit the same proof, but as user 2 and using pub key of user 2. And of course, it's not going to emit the same event. So I cannot show that it's not recorded because visibly I lost the address of Euler problem. But well, I don't have time to recover it. Maybe you have questions?
Yeah, thank you. I will just make addition. So actually, what I like that you really put some game of theory cases into your submission, like delay of making proof and restore by pin code. But why I point out for this SHA generation thing that I saw in your code, it's not related to the private input that you put inside. So it means that actually since this source code will be open sourced, and so people can just skip this section and just go, and it's easy to just eliminate this piece of code and just generate the proofs. So actually, I think to make it a really use case, a real example use case, so we need to somehow bind private input to SHA generation. Then we can't just skip this step if we have this code.
Well, actually, what the circuit is checking is not that the problem, that the Euler, the solution of the problem is the good one. It's checking that the 1 million hash of the solution is the correct one. So if you don't go through the 1 million hashes, you cannot actually verify. The circuit will not accept your solution. So when you generate the circuit at the beginning, the value you give for the solution is also goes through the 1 million hashes. So what is in the circuit is the solution after the 1 million hashes. So if you don't go through the 1 million hashes, your solution cannot be okay.
Oh, I see. So maybe I missed this step. And is it possible just to have a look for this constraint that check these hashes? Because I'm just wondering how it's calculated. In the
sorry, so it's, I think it's main CPP. So
yeah, I see it on main CPP file, but then like I want to see when.
So if you, for example,
checked.
Here you have computing 1 million hashes of SHA1. So then there are transfer the result of this hashes. So every time the loop goes one time more, its problem underscore s is updated. And at the end, problem underscore s is put in a passphrase 32 as 4 integers on the passphrase.
Yeah, got it. Okay. Yeah. Okay. Now. Okay. Yeah, I think I got the point. Okay. Anyway, I think we can ask. I can ask you more questions later when I will just check. But thank you for clarification. Yeah.
Okay, you are welcome.
Thank you.
Just a question. I mean, not about the technical solution, but about the code you're showing. Why did you use the Pico SHA module? I mean, there is something like this in the suite. I've just sent it to the chat. I mean, you could have used this. You could have used it without like using external modules, but just asking.
Because I didn't know that function was available in the library.
Sorry. Well, my bad.
To be honest, I am not a C++ developer, so it was I had to remember what I did 20 years ago.
Oh, okay.
And C++ evolved a lot in the meantime, so I didn't know. I didn't explore all the library, and if I had known that it was available, then I would have used it.
Okay, just a question. Okay, thanks.
Welcome.
Okay, Fabrice, are you going to make a presentation for the third use case?
Yes, if you want, maybe I can skip the demo if you want. I can just explain the ID unless you also want a demo. But the third use case is that when you publish, when you use a public key online, for example, in the multi-sig contract, sometimes you could lose it. You could lose the secret key that is associated with your public key. So the idea of this use case is that you are going to create a circuit with a passphrase, so something that you can remember easily. And then you are going to create a contract online that associates that circuit with that smart contract that contains your public key. And in the future, if you lose your secret key, you will be able to generate a proof that you know the passphrase, and that you want to associate the smart contract with a new public key. Once you have done that, so the smart contract is using zkSNARks to verify that you indeed know the pub key, so it verifies the proof. And so if you do that, internally in the contract, the pub key is your new pub key. And then from that contract, you can send messages to other smart contracts to tell them that you want to replace your old public key with the new public key. So, for example, we proposed a version of the Surf wallet, so setcode multisig wallet 2, where we added this possibility. And so in the demo, you can, for example, send a message to the setcode multisig wallet 2 contract and have a custodian key change by another custodian key just using the passphrase. So I think it's quite similar to what we have to the previous example. So I don't know if there is the need for a demo, but I can do it if you want.
Okay, got it. Anybody has any questions? No questions. Okay. Thank you, Fabrice. Thank you, Thomas, for your presentations. It's very interesting.
Thank you.
Okay, so now it's turn for the submission number 2 from Noam. Noam,
Hi.
please.
Yes. Hi. My submission was about anonymous vote. Just to define, anonymous vote is a vote where everyone knows what people vote, but they can't ID the voter. I'm not prepared to actually demonstrate, generating proofs and all that, because my circuit is apparently much heavier, and so it would take some time to generate proofs and keys and all that. And in addition, I, for some weird reason, can't deploy any contracts right now. And so I would have to explain only theoretically. Let me share my submission paper. There it is. Okay, so my goals when designing this anonymous vote were basically, you have a set of voters, any one of them can vote. The vote choices are, you can vote a large amount, you have a large amount of choices up to basically anything you can fit into unsigned integer of 32 bits. And though you can limit it through the smart contract. And basically, it had to be that anyone can vote, and there cannot be double votes, and no one can use man in the middle attack to replace one's vote. For example, while he's voting, to make man in the middle and use the proof. If the proof is not bound to one's vote, then you might be able to replace it. So one of the goals was to prevent that. So the way it works is each voter has a secret, and he sends a hash of that secret to the vote organizer. Only it's not a hash, it's actually an HMAC of the of some magic value. You can see it here, with the secret as the key of the HMAC. The reason I did that was because Knapsack, the zkSNARK friendly hash I used, has a problem with things like concatenation, and I needed to make, let's say, several other HMACs. So from a security standpoint, you know that you can't generate one HMAC for, if you have HMAC for message A, you can't generate an HMAC for message B from that. So I took that as a security assumption and ran with that. So I only ever use HMAC. So you send those hashes to the voter organizer. He deploys a contract which contains all those hashes and chooses how many votes there can be. That's not really important. And when, okay, so when someone wants to vote, he has to first prove that they know a secret, which its hash is in that voter set. The second thing they have to prove is that they are the ones who vote, meaning they have to sign the vote and send that with an HMAC of that, with that secret, and with proof that this is indeed an HMAC of their vote choice with that secret. And to protect from double voting, I basically added a requirement for the voter to send something I call anonymous ID, which is basically an HMAC of another magic value with that secret, which it identifies this voter, but you can't identify, you can't compute the secret or the secret hash, so you can't know who is the one who voted. You only know that if someone votes twice, he would have the same anonymous ID, and you can keep a set of all the anonymous IDs who already voted. Again, as part of the proof the voter sends, he sends a proof that this anonymous ID is indeed that HMAC. And so all three requirements I said are in one proof for an R1CS circuit. And the verification key is hard-coded to the smart contract because it has to be, they all have to, you can't trust the, it's obvious, I don't have to explain it. Okay. So when one wants to vote, he just sends his vote, his anonymous ID, the HMAC of the vote, and that proof. There are a few things that the maximal amount of voters currently set is 10 for simplicity, but it can obviously be changed. It's just a constant.
Okay, I'm sorry, no, time is coming out. So, I mean, we can read details in your presentation, in your submission. Do you have anything to add that there is no in the submission?
Yes, it's not technical, but I found out today that if I have a usage section and there are some commands here, and when you try to copy them, it adds a break line, which makes it a little painful to use in terminal. So I would just publish in the developer experience group my original document. You can verify that it is indeed identical to the PDF I submitted, only it would be easier to copy comments from there.
I got a question. You've been asking if you should like talk about the security aspects of this, and well, I'm gonna be honest. I've been asked about if your solution can be used like in large scale. So could you please, like, I don't know, express your security concerns? So just to show that this particular solution, I guess, has to be, I don't know, maybe adjusted to the large scale or something like this.
Can you repeat? I didn't understand.
You've been asking in the chat that if you have to express like those security concerns you have about the solution, maybe this is something which is worth expressing, I guess.
I can't remember any security concern because I tried to solve any security concern that that was raised, though I didn't make a serious security audit of the solution. But that's the reason I turned to use HMAX and implemented an HMAX component, because I realized that simple concatenation would have obvious flaws with knapsack.
Okay, what I was talking about is was something about like using knapsack at all, but okay, let's just say we could use some other hash and that would work. Okay, probably.
Noam, could you answer the questions from the chat?
Yeah, I can say, yeah, thank you, Noam, for clarification. Anyway, just Alex, just in case, what about the timing? Maybe we can say about how many times for next participants, how much time they have to present and how much time we have for questions, just to be in time.
Time was 10 minutes for presentation and 5 minutes for the question. Just I'm not very strict here because for me personally it's very interesting. So sorry, guys.
Yeah, it's okay. Yeah, but anyway, it's better to have a timing concerns. Okay, Noam. Yeah, is it right that you're using anonymous ID, like magic number? For now, is just your address, right? It's your public address.
Say again?
You said that you use anonymous ID, and as I can see, this is your public address that you.
No.
No? Okay.
No.
And what do you use?
Okay, it's right here. Let me find it. Yes, it's basically the anonymous ID is HMAX of 2 to the power of 34 minus 1, meaning 33 ones, where the key of the HMAX is the voting secret. So it would be different for every voter, but you can't compute it without knowing the secret.
But where do you get this anonymous ID?
What do you mean, where do you get it? Who generates it?
Okay, so it means like governance who generate this system voting.
No, the voter generates the anonymous ID. It's the anonymous ID isn't random. It's generated from the secret, from the voting secret. there is a voting secret that any voter generates first and sends the hash of that secret to the vote organizer. So the anonymous ID is generated from that secret.
Okay, so I missed the
deterministic.
step where you send this to voting organizer. Okay, I will check it out, and looks like
Okay.
it makes sense. Yeah. Okay, thank you. And what about the question that I sent? What about changing the vote? Is it possible, like not to make a double vote, but like change your outvote? So it's actually what Vitalik Buterin said 2 years ago. It's very important and it's quite challenging to make a voting system to protect from to make it bright resistance. So it means like if even anyone want to give you a bright, you can change your vote anonymously at any time. So is it possible to do this in your approach? To change your vote?
Right now, it's impossible. If you send something with the same anonymous ID, it would be rejected. Theoretically, it could be possible, as long as you make sure to add some assurance to have. For example, suppose I vote the first time, then I vote the second time. Someone might replay the first vote and change it back to the first choice I made. So you have to make sure you can know which vote was first, which is the latest vote, because since you can't have any timestamp, I can't think. Maybe you can. I can't think of a way. So you have to, I don't know, add some maybe the a version number to the vote to make sure it doesn't get replayed.
Yes, exactly. So it means like when you send transaction, the thing is, and why I also propose to use the Merkle tree, because you can send any votes and they will be stored in different Merkle tree. What you can do in hashing list and you can do in Merkle tree. So you can put all the votes, like you can vote anytime as much as you want, but and nobody wants like which vote is related to which person. And then you can just, the snark will calculate all the votes and accept only the last vote from your submissions.
But what if someone replays a vote you already sent?
So the snark will accept only the last vote.
Yes, but the first vote could be also the last. If you vote, for example, you vote yes at first, then you vote no, and then someone replays the transaction for yes.
But only you can replace it by, same with the HMAC, you can verify that only from your address or from your, you send only HMAC, so nobody besides this verification system knows who is after this vote.
Well, I think anyway, I think it's a question out of the scope of that contest, but
Yeah, exactly.
I would be happy to
let's
have it later.
Yeah,
Okay,
and okay, last question, the quick question about this hashing list. So is it right that like based on your code, as I checked, so actually we can see that by index mask, we can verify who is voting. It's anonymous, but public is index mask.
The index,
so if we know
the index mask isn't public. It's a secret. It's part of the auxiliary input, so it's not private.
and you
So
never
it's private.
check.
Sorry, it's private.
It's
The
private.
index mask is private. Yes.
Okay. Yeah. Okay. Thanks.
Only the
No
first
questions.
13 values are public.
Yeah. Perfect. Thank you,
okay.
Noam.
Thank you, Noam. So the next presentation should be for submission number 3. from Alexander. Alexander, please.
Not the right Alexander here, I think. The Alexander who made the submission.
Ideal atom. The name ideal atom.
Yeah, or Alexander AVD, not Alexander ZAT.
AVD is not that Alexander.
Not here. AVD
sure?
is idea whatever.
Oh, I see
And
he's
he's
here
not
and
here.
he's unmute. He's here and he's unmute, but we can't hear you, Alexander.
Which Alexander? Oh,
No,
he is
no,
here.
we
Sorry,
can't
he
hear
is.
you. Check your. Okay, he will try to again. Okay, since we have a time, just ping for next participant, just like to not. I saw this C note is here, the guy who will just check that. And he said that he not available to present it right now, but he can answer for questions.
Who is C-Note? What are you talking
Just in
about?
case, like, hey,
What,
C-Note is here.
what do
It's
you mean?
the guy who sent fourth application.
Submission number 4.
So yeah, but he's here. Okay, Alex, we
Hello?
can't hear you. Yeah, now we can. Yeah.
Oh, you hear me? Okay.
Yeah, please.
So, yeah, I will share my screen.
Okay.
Yeah. My submission was about a very actual problem about COVID and privacy tracking. And now governments really wants to track the spreading of COVID virus. So they want to let know where the people was. But it makes a real problem of privacy because nobody wants to share their real coordinates, say where they was. So, but we can solve this problem using zkSNARKs. And actually what I did in this submission. So we will prove that we didn't be in some dangerous area infected by virus without sharing our actual coordinates. I made a simple web application for demonstration. So let's assume this red square is a dangerous area, and we want to prove that our coordinates led not in this range. So now we're generating a proof of these coordinates.
So we could put the point to any place in the map, right?
Yeah. I can change it, and you can see that these coordinates are changing. Also, you can change the coordinates of this danger area. Take some time. Under the hood, I'm using the C++ tool for generating proofs, and I will show you later how it works. Oh, now we have proof. It's a proof and primary input concatenated together in hex format. And I forgot to say that in my snark, the user coordinates, so this pair coordinates, it's a secret input, and the coordinates of this, let's say, danger area, it's a public input for snark. So after I generate proof, we can verify it on a blockchain. And this web application using Tonos client JS library for communicating with blockchain node, and as you can see, it's an actual result from a blockchain. So the verification result is true, so this point not in this area. And let's say if we try to change the proof one symbol, the verification result should be false. And we can download this proof for using later, for example. So this web application consists of simple node backend using CLI tool under the hood, and the React frontend, which communicates with blockchain using Tonos library. And now I will show you how to work with the CLI tool. First, we need to set up a keys. With this command, we will generate a pair of keys, private key and verification key. They will be saved in separate files. It takes some time. So now we have two files, proving key and verification key. And now we can make a proof. So here the post lat at the latency position and post lang at its longitude position. So it's two secret inputs, coordinates of a user. And this one is just a minimum and maximum latitude and longitude coordinates. So basically our snark proving that the latitude position lies between these public input boundaries. And so the same for longitude. So now the tool loading proving key, which was saved later previously. Yeah, the tool checks that blueprint is satisfied, and now it's generating proof. And proof was saved in the file proof file, and also I saved primary input as well, because it's too many inputs. It's much easier to check, to verify without. Well, need to input this again. So when I call CLI with verify command, it loads primary input and proof and return the verification status. Here we check the proof using C++ blueprint library, but also I can verify it using a smart contract in new network. I have smart contract. I'll show you. Verification smart contract. It's very easy, just return Boolean if it's true or not. It takes proof plus primary input concatenated together in hex format. So I can try to use the same proof. And I run the verify function on this contract, given this proof. As you can see, the output is true, so this proof is valid. If I try to change one symbol, it shows false. So this proof is not valid anymore. That's it. If you have some questions, please welcome to ask.
Yeah, could you specify, you are verifying that point inside the boundaries
Outside.
or outside?
Outside. So let's assume that this area like very dangerous and have several COVID infected cases, and governments want to, I want to prove to governments that I haven't been in this area. So I make a proof that my coordinates are outside of this dangerous area without revealing my actual coordinates. So if I have such proof, the governments can be sure that I was in a safety place. And if I haven't such proof, that I need to contact governments and they want to track my health or something.
Okay. Anybody else has a questions?
Yes. Yeah, hello, Alex. Yeah, first of all, thank you for a lot of help along with Noam. You did a lot of things like to push it forward, all this development process. And I see by your GitHub, like you do a lot of like research and change. First, as Pavel said, you check, so you have constraints to verify inside. And I saw some kind of things that you verify in the circle. Like there is a constraint, but you change it later before you change it like range of specific area, right? Like I just want to like ask you some comments. Why did you change from a circle? Maybe it's related with the math or anything else? Because with the range area check, it looks like also very reasonable thing to check. And yeah, I really like that you have UI for your application and real use case that we have now in the world. Yeah. So what about the range check that you have in your commits before?
Yeah, actually, first I want to try to check that the given user coordinates are inside of a circle with a given radius, but it was really hard to apply the math because it's the formula. I need to use the harvesting formula to calculate the distance between 2 points on the sphere. So, and this involves like trigonometry functions like sinus, cosinus, square roots, and so on. And I decided it's going to be really hard to implement on the snarks. So I simplify the task and just check that coordinates are outside of minimum and maximum latitude and longitude coordinates.
Yeah, cool. Thank you. Totally makes sense. Yeah, thanks. Anyone else?
I have a question. How can you trust the coordinates if the client is the one who sends them? Can't you just fabricate whatever coordinates you want?
Yeah, this application is just for a demonstration purpose, but in real life, I assume that like every user gets some device from governments who want to track it, and the user cannot like somehow hack this device and like change the coordinates that send it. So my assumption was that every user has some device that send the real coordinates to governments for making proofs, but user cannot like interact with this device and replace the coordinates.
So it would have to be, in real life, it would have to be signed with some key, I guess, that would be inside
Yeah,
the
yeah, for sure.
Okay.
Like every device should have some key hard-coded. So every user should have each own proof, and all proofs would be connected with with such devices.
Cool.
Yeah, thanks, Noam. Good question, actually. And I want to add that Alex even put it in his submission PDF file. He also pointed out for this problem and say that how we can solve this problem to not falsificate with the wrong coordinates. But, yeah, nice.
Okay. Does anybody else have a question to any participant, please? No questions, guys? Everything is clear. Everything is.
But what about the first submission? See notice here, maybe we can just kindly ping him if he can add something from his side. Or Alex, what do you think? Or we can just send him questions later.
I don't know his Telegram account, so I don't know who is this guy. And I went through submission. Actually, he's
here. I see
really?
in the Zoom CNOT, so he's muted. But
CNOT?
CNOT is here, so that's why I say maybe he can add something or write.
Okay, CNOT, are you here?
Okay, or if you can't speak and as you said, maybe like let's write how we can reach you. So since anyway it's in the record, I can say I check his GitHub and looks like it's about the privacy, that in United States we have a problem with the how they can check everything about our amounts, and he implement something like this. Yeah, but it will be very nice to hear from here.
But how do you know that CNOT is the fourth participant? I mean, I didn't seen any contacts from him.
In the forum, he sent link to his GitHub and submission. So I think.
In the forum.
Yeah, he sent. So there is also valid use case with the encryption of the salary and amount. And okay, I'm here.
He's saying, sorry, it's hard for me to speak.
Okay.
Okay, so there is no presentation.
Okay, send your contacts then.
Yeah, please.
And we can contact with you and ask the question, or maybe. But in general, it looks like it's valid use case, and he promised that he can send deploy verification. His verification later, and we can check how it works. Or maybe he can write some video. I don't know. Like record some video.
Может, просто другой язык.
Yeah. Maybe he don't know English. I don't know. Yeah. As Mikhail said. Okay, let's
wrap up. Yeah.
Later.
Okay, so if nobody has any questions for any participants, so let's make a final countdown.
One thing. One thing
Okay.
About Thomas and Fabrice's submission. Is that going to be considered as one submission or 3? I just wonder. How is it supposed to be rated? Scored?
Good question.
That's a good question. Actually, I have no clue, Fabrice, why you didn't submit 3 work. Why
Yeah.
all in one?
Actually, we didn't submit 3 because there are contests where you can only send 1 submission per team, and in this case, we didn't know if there was this limitation or not. So we decided that we would submit just 1 submission with the 3 use cases.
Well, there are 2 of your folks, so I don't know, at least 2 teams consisting of a single person.
Well, we did the work together, so it's even if well, yeah, we could have submitted as 2 persons, but
Like,
yeah,
we don't mind. I guess nobody mind.
Okay.
Okay,
I
then we
think
will
it
again have
works.
some technical problems with that, but
So
I mean,
right now all submissions are passed. So right now,
yeah, we can reload.
There will be one more contest about it, so just think, why not?
yeah, it's difficult because right now it goes like 1 submission, and there is no way to make it like 3 different submissions. For example, for jury members, for assassins, for judging. So I don't know if we could agree that we could, for example, make assessment for the first use case and put other 2 use cases to different contests. It is only way we can solve this, as I can see.
Not the first. I mean, you can choose. I mean, probably can, but again, that's not fair because they prepared 3 to this one in time.
Fair for whom?
For them.
For Fabrice?
Yeah, they prepared three work, 3 submissions.
Yeah, but why did they put it as a 1? Why didn't they ask, and why didn't they try?
Yeah, so general rule, if you don't understand something, please ask. That's a general rule.
Yes, maybe you're right. I mean, I think we didn't want to. We perceived that maybe it would be unfair for us to make several submissions, even though we use joint work, and also because we use FT, because we use very similar code, we felt it would be more coherent for the jurors to just look at 1 repository. So I don't know. I think it's really up to the jury. I don't know what you guys think.
Well, we said in the submission that it was up to the jury to decide if they wanted to keep it as 3 solutions, well, as 1 submission or as 3 submissions. So, I mean, we don't mind if you choose 1 or another one.
It's not for the juries to decide. It's this solution is for organizers of the contest. It's not for the juries. Just they have 1 submission and they cannot decide. It's only 1 submission right now.
Yeah, because we vote in blockchain, not in Excel.
Yeah.
Well, if they don't care, then maybe we shouldn't work so hard. But theoretically, we could make another contest which you could, which only they would be able to submit to, and it would be for 24 hours, and then the voting will start for that. I guess
We already agreed to have contest A1.B for 2 weeks from last Vex meetup. So we already agreed to have it.
Yes, but it's a different case. In the second contest, we said there would be a lower reward because people didn't submit on time. But here they did submit on time, only in an unusable form.
In a wrong way. It's the same.
Yeah, we can all open a new contest where, I mean, for like 24 hours where you can upload your work. That's for sure, and you will be able to reload them. That's what can be done, because before jurors voted, then no, like we can again relaunch or deploy new smart contract if it is.
Okay, I got a question. Let's just host one more contest with the same terms, same timings, like whatever. One more contest, the same. I mean, I'll just change dates, and that's it. What do you think?
Yeah, which doesn't solve the question. What we're gonna
Well,
do with
just a new submission. Why not? I mean,
Mikhail, let me explain. In this case, we will repeat the same contest with same terms and rewards. It will be unfair for the participants who submitted their submissions already. So, because other participants could use their submissions and base their research on the work
well,
previously done.
Okay, let's just add one term on, like, without duplicates. Okay, just exclude the duplicates. That's it.
It's very hard to check it, George.
Okay, well.
So the most like reasonable for me is we are making like part number 2, the contest, and we start. We could reward first 4 places as it is, and the next contest we could start reward from the 5th place.
Yeah, that's what we already agreed. That's we already agreed.
Okay.
Just, I mean, if Fabrice and Thomas are fine with having this as one submission, then that's fine, because then we don't have a problem. That's I guess that's more or less their decision.
Well, we are fine with keeping it as just one submission. There is no problem with that. It was submitted as one submission, so of course, no problem if it is judged as one submission.
Okay, so then we don't have any issues.
Okay, and Pavel, Alexander, what about the like submission, like part B, as you say, or part 2?
Yeah, it should be.
You didn't announce any timings about this.
Timings.
I want to know like how much time I have to prepare for
yes,
this.
but you asked, and I think we will put. I hope we'll put it on to vote today or something. You asked 2 weeks from last Thursday, so 2 weeks from last Thursday.
Yeah, because I just want to say like there is no announcement.
Yeah,
so
I know.
In case someone else wants to participate, they want to know about this in advance.
I mean, technically, if you prepared that, if you have been prepared that proposal, then we could have put it onto the vote. The problem is that you don't know how to do it, so that's why I didn't ask you. But I didn't have time on the weekend. But today we'll put it on vote. So everybody can create such documents. And
I'm not familiar yet, so if you can.
Yeah, that's I know. That's
if
why
it's easy for you, I will be glad if you can.
What are the timings for this second part? I
2 weeks from the last Thursday.
Oh, okay, great. I mean, it will start like last Thursday.
Yeah, whatever. I mean, the ending is only one date.
Okay, 2 weeks. Duration is 2 weeks.
Yes.
Okay, so guys, let's make a finish countdown. If nobody has any other questions, 5, 4, 3, 2, 1, 0.
Bye
Thanks,
bye.
everybody. Thanks for this
Thank
one.
you, everyone.
Bye. Thank you.
Bye.
Bye.
Ciao.